Our solutions to perfect problem 1 for math 111. This is the paper folding example. So what I give you here is I say that a standard piece of paper is 0.1 millimeters thick, which is more or less true, I believe. And then we're going to fold it in half, so each time we fold it, the thickness will double. And we're going to do it a bunch of times. We're going to do it 50 times. So the first step here is it just wants me to express the thickness of the stack in millimeters. And it wants me to write it in this form. What I'm saying is you could think about the thickness, thickness as, well, it starts out as 0.1, and then we're going to multiply it by 2 every single time we fold it in half, right? Because it doubles each time. So after you fold it once, it's 0.2. Fold it again, it's 0.4. Fold it a third time, it's 0.8. Keep doing that, right? Keep multiplying by 2 50 times. You want to multiply it by 2 50 times, so what you get is 0.1 times 2 to the 50th power. I don't know if writing 2 helps you, but if it helps you see it, fine. This is the thickness of our stack. So all this question is asking us to do is figure out what the hell this is equal to. It's this many millimeters. I don't know, you can write millimeters if you want, you don't have to. Okay, and the way we're going to do that is following these steps. In step 2, it says use your exponent rules and rewrite this in the form that equals 0.1 times, and then it wants me to do something raised up to the 10th power, raised up to some other power. Okay, that something should be 2, because over here I have 2 to the 50th power. So 2 to the 10th raised up to the 5th would be the same as 2 to the 50th. So I can rewrite this in this form. I don't know if that was clear or not. Hopefully that makes sense. In step 3, it says 2 to the 10th power is 1024, but instead we're going to assume it's 1,000. Instead of 1,024, assume it's 1,000. This 2 to the 10th right here, assume it's 1,000. It'll make the calculations easier. It won't make a huge difference. Use this fact to rewrite your answer from step 2 in the form 0.1 times, now in our parentheses here, I want 10 raised up to some power, raised up to the 5th. Because C, we figured out in step 2, was 5. So, okay, 10 to what power is the same as 2 to the 10th power? I can get that from this little hint. It says 2 to the 10th power, assume that's 1,000. And 1,000 is the same as 10 to the 3rd power. So this is 10 to the 3rd to the 5th. Okay. In step 4, it says, now use your exponent rules again. 10 to the 3rd to the 5th, that's just the same as 10 to the 15th, 3 times 5. And that is the same as 0.1 is the same as 1/10. So 1 over 10, I don't know, 1 over 10 times 10 to the 15. In other words, it's 10 to the negative 1 times 10 to the 15. And it's just 10 to the 14. So my answer is my stack of paper is 10 to the 14th power millimeters thick. So what? That doesn't tell me anything. 10 to the 14th power. Let's figure out what that's equal to. Well, 10 to the 14th power is a 1 followed by 14 zeros. 1, 2, I guess I'm really going to list them out. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 10 to the 14th is this mess, this many millimeters. I want to convert that into meters. So the way I can convert that into meters is I can multiply. So how about this many millimeters is the same as, there is 1 meter in every 1,000 millimeters. So I can kind of cancel out some zeros. There's lots of different ways you could do this. Here's one way to do it. Cancel out these 3 zeros with these 3 zeros. And what you get is that we have 10 to the 11th, or 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 meters. So my stack of paper is this many meters tall. You do those steps one more time, converting them to kilometers, and what you'll end up seeing is that it's 3 less zeros, kilometers. So my stack of paper is 100 million kilometers thick. It's a lot of kilometers. It's very thick. I think I say put that into context. How far is that? Well, distance to the, maybe I need another color here so things don't run together. Distance to the sun is, I Googled it, it was about 150 million kilometers. So we're not quite to the sun. We're what, 2/3 of the way? We've gone 100 million kilometers. We need to go to 150 million kilometers. So we're 2/3 of the way. To the sun. And for the moon is 385. Let's write this distance to moon. It's approximately 385,000 kilometers. So we're way past the so we're way past the moon. Let's see, I guess if we are 100 million kilometers, 3 times the distance to the moon would be about 1,000,000 kilometers. So we're roughly 300 times past the moon, whatever. We're way past the moon. The point that I'm trying to make is you can use some exponent rules and figure out that if you could fold a piece of paper in half that many times, you can't, try it, you can't. There's a reason why you can't, because it'd be way too big. But if you could just fold it 50 times, your stack would be 100 million kilometers tall, which is almost the distance to the sun, 2/3 of the way there. So I guess that's the end of this problem.